Good morning, good afternoon, good evening. So today I would like to share something that is related to the testing of your RAG applications. So one of the often discussed topics is, how do you know that your RAG application or your RAG application is performing properly in terms of the quality of its answer? Is it correct? Is it relevant? Or more seriously, is it making some unsubstantiated claims, what you call hallucination? So, of course, you can go by gut feel, right? You just run the application and then you get your friends to assess the answers, or you get a panel of experts to assess your answers. But this approach will not scale because if you put your RAG application into production. Now, I know we're talking about final year projects for most of you. So production is something that's kind of far away. But let's extrapolate the scenario to a real-life situation. If you make an update to your knowledge base or the application, you may not always have the luxury of contacting your friends or panel experts to test things out, right? So how do you know then your app is continuing to behave properly? You need some automated means to do so. And this is what I want to cover today. How do we ensure that your RAG application is performing at a basic level of proficiency? All right. And we're going to make use of a framework. You don't need to scratch build of this. It is actually quite simple to do so. Okay. So we are going to make use of this framework called RAGAS. All right. So this is the URL for RAGAS. And basically, RAGAS is a library. Oh, let me identification so it's a bit easier to see. Okay. So RAGAS is the library that help you move from the vibe checks. Means you ask your friends and yourself to do the testing to get a feel of whether it is working out correctly. That's a vibe check to systematic evaluation loops for your AI app. Okay. So RAGAS actually can test quite a few things. So if you look at the documentation here, it's quite elaborate. But today, we are primarily interested in the RAG application. So you have metrics for RAG application, agents, NLP, SQL, etc., etc. But we are just confine our discussion to the RAG applications. Yeah, RAG applications. So they have predefined metrics for you to assess the quality of your RAG application. And you can, in fact, define your own metrics as well. But there's no need to do that because they have already packed the heads for us. So we just make use of whatever they have. But there's nothing to stop you from saying that I want to have a very special set of metrics for my application, and I'm going to define them accordingly, because these are just prompts to the LLM. So when I say prompts to the LLM, RAGAS, actually what it does is that it takes your RAG answers, right, which is an answer generated by an LLM of a choice with context being given from the knowledge base, right, and it ask another LLM to do the evaluation. Okay, and what LLM you're going to use is up to you. So this one I'm going to show shortly. All right, so I have created a very simple Jupyter notebook to demonstrate this. Right, and we're going to make use of the RAGAS framework to do so. Okay, so for starters, okay, you need to import some libraries, nothing special here. Then in this case, I'm going to make use of IBM Granite LM to access the answers. Okay, so since I'm going to use the Granite LLM, of course, I would have to put in certain definitions and have to set up the Watson X LLM client. Now you can use anything you like. You can use ChatGPT, you can use Gemini. It's up to you. But of course, if you're going to use Gemini, then this setup will be different. If you're going to use ChatGPT, then the setup is different. So here for demonstration, I've made use of Watson X. Okay. So you run this, install the library, you run this, it set up the LM, nothing special. So the magic is here. All right. So in order to test if your RAG application is performing properly, you need to have test data. So test data is in this format. So this is the question that's been asked. This is the answer that's generated by your app, and you're trying to assess if this answer is good enough. Then context, this is the supplementary information that is tied to the question that's been asked and then passed to your RAG LLM, and your RAG LLM actually makes use of this context to come up with this answer, right? This part comes from your knowledge base, right? So this is the question, okay? Instead of just pushing this question to LLM and getting an answer, you take this question, then you do a retrieval from a knowledge base. This becomes your context. So this piece of information and this piece of information is bundled together in a prompt and then sent to the LLM. LLM will return with an answer, which is this. Now, most of you have already done this in a very basic form. Okay, so how you're going to extract this, do a little bit of research, right? Now this one and this one, certainly you can extract, no problem, right? And then you need to have the reference. What is the perfect answer? Now for simplicity, in this set of test data, there's only one question. There's only one question. There's nothing to stop you from populating these into a database or in a spreadsheet or in a .csv file with hundreds of questions, answers generated by your application. What is the context from your knowledge base that help your LM to give this answer? And very important, what is the perfect answer, the reference answer or the ground truth? Because you're trying to access your LM, your LM, right? There must be the answer. Just like your market examination paper. How do you know this is a good answer? The marker must have the correct answer, the perfect answer to gauge, right, how well the student has answered. So it's the same. To judge how well your LM has answered a question, you must have this model answer. Okay. Now here, like I said, for demo purpose, there's only one question, but there's nothing to stop you from having a set of hundreds of questions. So that's up to you to generate. As a project team, you need to know, right? How good is my RAG application? Absolutely, you need to have this. You must have some idea. What are the perfect answers for each of the questions? Okay. Now I use the word, I use the number hundreds. Okay, maybe not hundreds, but at least you must plan on maybe 30 to 40 questions in the test data set. Yeah. Okay, so there's some admin here. You need to set up the data set using the data set, the object, the RAGAS aspect. And then here, you want to choose the metrics. So the number of matrices here. So I'm going just to choose 3. I'm going to choose faithfulness, noise sensitivity, and context precision. You can choose all, And you can even add your own. Now, adding your own, I'm not going to go into that because, let's not be too ambitious. Let's start with something simple. After that, you just run it, right? Yeah. And then just print out the result. That's all. So here you can see it runs, and then you say, okay, what is the overall faithfulness score? Now here, this is the overall score for this set of questions. We happen to have only one set of questions. So if you have 100 questions, then this is your overall score of your RAG application for that 100 question. Okay? Okay, let's take a look at what are the questions. So the question is, what is the capital of France? And what is the key landmark there? The perfect answer is the capital is Paris with the Eiffel Tower as its most famous monument. Right? And the answer is given by the RAG LLM is the capital of France is Paris, and it has many excellent restaurants and shopping centers. So again, this is a little bit off, right? And this is really to demonstrate, right? Not so good answer. But of course, this answer wasn't plucked out of thin air. There was some context given to it, and the context is made up of these 3 sentences, these 3 pieces of information. France is a developed country in Western Europe. Paris is the most populous city and city governance, and French is the producer of wine and cheese. Now, I know this one look a bit suspicious, so this is deliberate to illustrate how the metrics work. So we access, and we say, okay, overall faithfulness score, wrong here. Overall faithfulness score, 1.
Could you please provide the specific text or example?
Overall faithfulness score is 1. Noise sensitivity score is 0. The context precision score is 0. Are these good score? Okay, these are not good score, but let's go into each of these matrices. Okay, so it's a faithfulness score is 1. So what is faithfulness? So we go to faithfulness. Okay, faithfulness measures how factually consistent a response is with the retrieved context. Range from 0 to 1, higher score, better consistency. Okay. So really, it's just the number of claims in the response supported by the retrieved context and the total number of claims in the response. Okay. So number of claims in the response supported by retrieved context, total number of claims in the response. So from here, it concluded that based on the response, right, the response here, the claim is the capital of France is Paris. And it has many excellent restaurants and shopping centers. Okay. Here's a claim. So 1 claim. Number of claims supported by the retrieved context. So here, say, France is a developed country in Western Europe, and Paris is its most populous city and city of governance. Right? So it seems that based on this example, it concluded that actually it has only made 1 claim, which is the capital of France is Paris. Right? It did not access this bit, and it concluded that the capital of France is Paris because in your context it says Paris is the most populous city and city of governance. So city of governance implies capital, right? So total number of claims and response is 1. Number of claims and response supported by retrieved context is 1 because this statement is in fact supported by this statement. So 1. So 1 divided by 1, therefore the score is 1. Right? Okay. So what we're trying to say is that the answer, okay, generally was derived from the context that is given. The context is given. Okay. And next we have noise sensitivity score, and it's scored as 0. So what is noise sensitivity? Measures how often a system makes errors by providing incorrect responses. So total number of incorrect claims in a response divided by the total number of claims in the response, right? So they say each claim in the general response examined to determine whether it is based on a ground truth and whether it can be attributed to relevant or irrelevant context. So the claim here is that the capital of France is Paris. Okay. So they say that the score is basically 0, 0, means that it did not make any claim that is making use of irrelevant response, making use of irrelevant documents or it deviates from the ground truth. If you look at this particular statement, the capital of France is Paris, right? Paris is the most populous city in city governance. Okay, so there is some relevance to it. And the model answer said Paris is the capital, and I say it's Paris, right? So in other words, it didn't base its answer on anything that is irrelevant, right? So therefore, it is 0, right? 0. So if there is some irrelevance, that yes, somehow, based on the incorrect documents, right? Incorrect or something that's not from answer, then this one will be more than 0. So 0 is okay, it's reasonable. Then the context precision score is also 0. So context precision, what is this? Okay. Evaluates the retriever's ability to rank relevant chunks higher than irrelevant ones for given query. Okay, what does it mean? Actually, the explanation, it has a better explanation here. Sorry, I'm going to sneeze. It basically says, evaluates whether retrieved contexts are useful for answering a question by comparing each question against a reference answer. So this is our context. This is the reference answer. So they are saying this context, how close is it to the reference answer? In other words, how helpful is it to generate a good answer? So I say Paris with the Eiffel Tower, as most famous monument. Okay, so they say the context precision score is 0. Context precision score is 0. So of course, 1 is a better score than 0, right? 1 is a better score than 0. So in other words, here we are saying that it is not very good. Why? Why? Because the answer is Paris is the capital, and the Eiffel Tower is its most famous monument. So nowhere in this particular context it says Paris is the capital. All right, and nowhere does it mention the Eiffel Tower is actually the most famous monument. So this, in other words, your knowledge base is not complete, it's not correct. Okay. right? So if this is the perfect answer, then your knowledge base somehow, whether it is a chunking strategy or it's a retrieval method or something, it's not quite right because it is not able to contribute to the perfect answer. So therefore, the score here is 0. Okay. Now, this is a negative demonstration. That's why I said prepare bad demo. Okay, so let's look at a good demo. So I just adjust the question a little bit. What's the capital of France? What's the key landmark there? The capital of France is Paris, and the most famous landmark is Eiffel Tower. This is the red LM answer. This is the context, right? Paris, the capital, most popular city, Eiffel Tower, blah, 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 blah. Most visited paid monument, Louvre Museum. Then France famous for wine and cuisine. Reference. Paris, with the Eiffel Tower as its most famous monument, no change. So again, let's look at the 3 score. Okay. Now it become 1, 0, and 1. Right. So faithfulness is 1 because you find that, see, the capital of France is Paris. Paris is the capital. The most famous landmark is Eiffel Tower, right? See, Eiffel Tower, city's most visited paid monuments. So every single claim that it makes an answer is actually derived from the context. So the perfect score of 1. Okay. Next one. Noise sensitivity score is 0. Okay. Noise sensitivity score is 0. So again, what is noise sensitivity? Let's revise. How often the system makes error by providing incorrect responses when utilizing when utilizing either relevant or irrelevant retrieved documents. Total number of incorrect claims in response, total number of claims in the response. Now in this case, there are no incorrect claims. Yeah, so therefore it is 0. Overall context precision score. So how good is the context in contributing to the final answer, right? So more look at this. Context precision score. Okay. Whether retrieved contexts are useful to answer whether retrieved contexts are useful for answering a question by comparing each context to the reference answer. Okay. This is the reference answer. So Paris, Eiffel Tower, the most famous monument. Paris is the capital, most famous is the Eiffel Tower. So the context actually contains the information, all the information that is in the textbook or model answer. So therefore, it is a 1. All right. So you can see, right, this set of data and this set of data actually will result in different scores being generated. Now, let's say it's just a simple tempo. All right. So in your set of test data, if you choose to do this, then you have many different questions, right? And the answers will be possibly somewhat more complicated. Now, to achieve a good assessment, you need to have a good number of questions. Honestly, how many, I don't know, right? But like I said, since we don't know, a good benchmark would be maybe between 30 to 40 questions. Now, more the merrier. But of course, I understand it is not easy to come up with good reference answer. But that's your job, right? You are the one to develop the RAG app. You cannot develop an app without knowing what is the desired behavior. And the desired behavior is driven by this. You must know for the questions that typically posed, what is the textbook answer? Only then you can access if your RAG application is performing properly. Okay. Now, this particular notebook is actually available in the Docling demo GitHub repository. Is here, right? You can see RAGAS example Python notebook. All right. Okay, so I hope that was useful, and hopefully during our final assessment, we'll see student teams coming up with solutions that include automatic assessment of the RAG-LM answers. All right. Okay. Thanks for listening, and bye-bye.